In our previous video, we took a look at how we could take a z-score and find the corresponding probabilities to the left or to the right on the standard normal curve. This time, we're going to go the opposite direction, and we're going to know the area of part of the curve, and we're going to attempt to find the z-score that goes with that area. To find the z-scores, we're going to use on Excel the inverse normal command, which is equals norm.s.inv for inverse, and then in parentheses, we're going to put the probability. This command will give the z-score with the area of the probability on the left. Everything with the normal distribution on Excel is always talking about the left. So if we want the right area or something different, we might have to account for that a little bit. But let's take a look at what this looks like on Excel. As with any continuous distribution problem, we're going to start by first drawing a picture to help us identify what we're exactly trying to find the area of. So for this first problem, we want an area of 0.83 to the left. And so if I draw my standard normal with 0 in the middle, I want the area to the left to be 0.83. That is more than half. So because it's more than half, I know I need to put more than half of the area to the left. And that area is 0.83. And we're looking for that z-score that's going to give us that value. Well, fortunately, Excel does do area to the left without any problem. So we're going to type in equals norm.s.inv. The inv gives us the inverse. We have the area. We want the z-score. And the probability we want to the left is 0.83. Put that in parentheses. And when we hit enter, we find the z-score that corresponds with an area of 83 on the left, 0.83 on the left, is 0.95. Areas to the left are not too difficult to do. But if we want the area to the right to be a certain amount, we're going to have to be a little bit more clever with how we do it. We want 0.12 to the right. That's less than half. So we want less than half of the graph to the right. We're looking for this tail. And we want to know what z-score gives us 0.12 to the right. The catch is Excel always gives area to the left. And so we're going to have to use the fact that we know the total area of any probability distribution is 1.0. And if we subtract off the 0.12 that's to the right, that's going to leave 0.88. So the area here to the right is 0.88. So that's actually what we're going to ask Excel to find. We're going to ask Excel to find an area to the right of 0.88. So we'll do norm.s.inv for the inverse. Because we know the area, we want the z-score. An area of 0.88 in the parentheses tells us that that z-score that gives us 0.88 in the left, 0.12 in the right, is about 1.17. We could also look at a similar problem here where we want to bound the middle 80%. We want to set this up so that we can find the z-score that puts right in the middle of the distribution 0.80. What are the z's that do that? There'll be a negative z and a positive z. What's nice about this problem is because we want to bound the middle 80%, it's symmetrical. So whatever z is, we've got the positive on one side and the negative on the right side. So that's nice. We need to know how much area is in the left tail because Excel only does left tails. A couple ways we can figure out what that area is. One way is we know the entire area under the curve is 1.0. And if we subtract 0.80, that's going to leave 0.20 left. But that 0.20 is actually talking about both tails combined. Knowing that it's symmetrical, though, we can cut that 0.20 in half. And we know there is 0.10 on each side. We want that left tail of 0.10, so let's have Excel figure that out for us. We'll say equals norm.s for standard normal, .inv for the inverse, and then in parentheses, we'll put the one that gives us area in the left, 0.10. And when we hit enter, we get negative 1.28. That z value that puts 10 in the left is negative 1.28. And the z value on the right is a positive 1.28. And now we know between a z value of negative 1.28 and positive 1.28, we catch the middle 80% of area. When we're using the inverse standard normal command, we know the probability, and we're looking for the z value.